Welcome to the improved Euler's method. So the general idea here is Euler's method assumes that essentially the solution maintains the same slope for an entire interval, right? So Euler's method assumes that the solution maintains the same slope for an entire step. But in most cases, as soon as we move away from that initial point, the slope will likely be changing, right? So improved Euler's method uses a second point and the slope there and sort of averages the two slopes. So improved Euler's method uses a second point to find a second slope. And then uses the average for the line approximation. So it uses the average of the two slopes for the line approximation. Or linear approximation. So I'm going to first sort of show the algorithm graphically, and then we'll go more specific. So if we take our initial point, x naught, y naught, and then we take its slope. So here's the slope in the direction field. And then let's go ahead and extend that line using the tangent line approximation for our whole step. So this distance will be whatever our step is. So here's where we started. Then we're going to take that second point. We are now going to find the slope of that second point. And then what we do is we average those two slopes. I'll stick with the same color. So next up, we will average the two slopes. From point 1 and 2. And then we'll take that average. So we had one that was like this and one that was like this. So the average should be somewhere sort of in between, right? So I'm going to do that one in a new color. And we're going to take that average slope and extend that. And then this will be our new point. well, we'll use the average slope for our new linear approximation instead of using the original tangent line. So this is kind of taking into account that the slope changes. We think maybe the average slope between the start and the end of the first approximation will be the best bet. So your textbook uses K for these slopes, so we will do the same. So the first step is to find the tangent line approximation. For y at the initial point x naught, y naught. Then we will use that tangent line approximation so we'll use that tangent line approximation to do an initial estimate for y of xi, or sorry, of y of x1 where x1 is the initial x value plus the step. Next up, we will find the slope. Oh, I should say here, we'll go ahead and call the slope K01 for from the point 0, slope 1. Here, now we're going to find the slope at x1 comma our initial estimate for y of x1. And we'll call this K02 for our second slope. Next up, find the average of the two slopes. So K01 plus K02 divided by 2. And we'll call that K. Then we're going to find the equation for the line. Through the point x naught, y naught with slope K. So that equation would be y is equal to, well, this will be our approximation. Y is approximately y naught plus K times x minus x naught. Then use that line to approximate we'll just call that y1, which is going to be y0 plus k times whatever your step is. Then we'll treat x1, y1 as our new initial condition. And repeat the steps. So we could rewrite each of our initial values. So instead of using x0, y0, we could use xi and yi. We could call the slopes ki1. We'll do an initial estimate for y of xi plus 1. Again, where xi plus 1 is xi plus the step. We'll find the slope at xi plus 1, comma, our approximation for y of xi plus 1, or our initial approximation here. We'll find the, and this slope is called ki2. We'll find the average of the two slopes. So k is, we can actually call this k0, and here ki is ki1 plus ki2 over 2. We'll find the equation for the line that goes through the point, xi, yi, with slope ki, and the equation would be y is approximately yi plus ki times x minus xi. We'll use that line to approximate y of xi plus 1. And that'll give us what we call yi plus 1, which will be yi plus ki times the step. And then we'll treat xi plus 1, yi plus 1 as our new initial condition, and of course repeat the steps. And then we stop once we get to our desired x value. So stop once we reach the desired x value. In the next video, I will show you how to do this in Excel. You definitely do not need to do this by hand ever.